In the Week 3, Lesson 3 video 2x2 matrices, you learned about a very special scalar associated to every 2x2 matrix called the determinant. By Theorem 3.8, this determinant determines whether or not the matrix is invertible. You'll learn in the next lesson that we can do this for square matrices of any size. In this lesson, you'll learn how the determinant is defined in general, and you'll learn two ways to go about actually calculating it. To give you a taste, let's see what the form the definition takes for 3x3 matrices.
To do the 3x3 case, let's take a look at this matrix. We then make the following definition for the determinant. The determinant of this matrix A is defined, I'll put a little DEF above here for defined, to be A11 times the determinant of the smaller matrix A22, A23, A32, A33 minus A12 times the determinant of the smaller matrix A21, A23, A31, A33 plus A13 times the determinant of the smaller matrix A21, A22, A31, A32. To help us better remember what these smaller matrices are, you can note that we get them, so if we're using this starting part here, we have A11, then we remove, or rather, let's put that in red, we remove the row and the column that it's in, and we're left with the matrix A22, A23, A32, A33. Then for A12, we look at that entry and we remove the column and the row that it's in, and we're left with the matrix A21, A23, A31, A33, and similarly for A13. To simplify the notation a little bit, let's make the following definition. We write Aij for what we get for when we delete row I and column j from A. It's unfortunate that we're using A sub ij here, capital A sub ij, to refer to this and to the ij index, but whenever we're talking about determinants, this notation here always means this. So using this, our definition then becomes the determinant of A is A11 times the determinant of big A11 minus A12 times the determinant of A12 plus A13 times the determinant of big A13, which we can even put, if you know summation notation, we can write this as sum from j equals 1 to 3 of minus 1 to the I plus j times A1j determinant of big A1j. These determinants in the formula have special names, so we call the determinant of big A sub ij the ij minor of A. I don't know why it's called a minor, but it is. Let's look at an example of calculating this. We have this matrix here. Using the formula above, we get that the determinant of A is equal to, let's see, what's in the 1, 1 entry? That's a 1, so 1 times the determinant of what's left over when we remove this row and that column. So the determinant of 1, 4, 1, 2. Then we have to do minus, you have to remember the minus, 2 times what's left when we remove this and that. So determinant of 0, 4, minus 1, 2, plus, let's see, this is going to this time be 3 times what we get when we remove this guy and this guy. So the determinant of 0, 1, minus 1, 1. Then calculating these, we get 1 times 2 minus 4. This is using our formula for 2 by 2 matrices. Minus 2 times 0 plus 4 plus 3 times 0 plus 1, which is equal to minus 2 minus 8 plus 3, which is negative 7. One last point before I end the video. In week 3, lesson 4, you learned that a non-square matrix can never be invertible. So since the main use for the determinant is, well, to determine whether a matrix is invertible, it doesn't really make sense to define it for non-square matrices. Therefore, we leave the determinant of a non-square matrix undefined.